Okay, let's start. Right. Okay, good evening. Let's start. Am I audible? Okay. Audible, right? Okay. Okay. All right, then we'll start. So today we are with day 15 of S2A discussions, and today I thought of discussing some structured essays from current electricity. Right. Last 2 weeks we discussed MCQs from current electricity. Basically, it covers Ohm's law, right? Ohm's law, Kirchhoff's laws, and voltage divider, right? Those areas. And today, I thought of discussing some structured essays, right? Especially uh, meter bridge, potentiometer, then the other creative experiments that has come already, right? So those are the ones we are going to discuss today. If you didn't get the questions yet, either you can go to the live chat here, right? There's a pin message, right? Go to that link and you can get it downloaded, or else in the video description also, the link is put there. You can go there and get it downloaded, right? Then in terms of the duration you have now, we are like 9 weeks and 3 days from the exam now, right? 9 weeks and 3 days. So that is not a huge time. That is not a huge time. That is not a huge time. It's a very short time period now, and when it comes to last weeks, final weeks, always when we have more workload in our subjects, right? Time flies, right? That is how it is, right? Always in all three subjects, you will be seeing kind of a increased workload, right? Not only in my subject, right? In all three subjects, you will see the same, right? Then what happens is, when you are busy with those things, right? When you are busy with those things, you don't feel that time passes, it flies. It flies. That's the thing, right? Then it will fly away in a less time as you think or as you anticipated, right? So utilize your time, manage your time wisely, and utilize it wisely, right? So that's how it should be in these days, right? Okay, then let's go to the discussion. Without any further ado, let me share my screen. Okay, my screen is visible, right? Right, visible now? Right, let's start. First one. An experiment can be designed to determine the internal resistance R naught of a voltmeter V using setup shown in the figure 1. E naught is the EMF of a cell with a certain internal resistance. E naught, right. R naught is a fixed resistance and R is a resistance connected across X and Y. Across X and Y, okay. X and Y is given. Assume that the ammeter A has negligible internal resistance. Ammeter has negligible internal resistance, then internal resistance of the ammeter is here, that is negligible. This is R equals 0, right? Assume that, all right. Then first one, A. When the voltmeter is connected across XY as shown in figure 1, first one, draw below the relevant part of the circuit to show as to how the resistance R and R naught appear across the points X and Y using circuit symbols. Right. We know voltmeter is connected. Voltmeters are connected parallel to the circuit, no? Right. There is a point here. Voltmeters are connected parallel to the circuit. Right. Voltmeters are connected parallel to the circuit. Right. Voltmeters are connected in parallel combination, no? Voltmeters are connected parallel to the circuit, parallel combination, right? Now between X and Y, this given R is already here, right? And voltmeter is connected parallelly. When voltmeter is connected parallelly, we have an internal resistance for the voltmeter, right? That is given as R naught, right? Yeah, internal resistance of the voltmeter is R naught. Then that R naught will be connected parallelly. That R naught will be connected parallelly because we are connecting a voltmeter parallelly between X and Y to measure X and Y. Then R naught is connected parallelly with this, right? Draw below the relevant part of the circuit to show how the resistance R and R naught appears, right? Then no need to draw the voltmeter, only the resistors, R and R naught, right? Next, write down an expression for the equivalent resistance Rxy across X and Y in terms of R naught and R, right? Now that is very straightforward because R and R naught are in a parallel combination, right? R and R naught are in a parallel combination. Since they are in a parallel combination, you can simplify that resistance as two parallel resistors. Then 1 over Rxy equals 1 over Rxy equals 1 over R naught plus 1 over R. Simplify this, right? Then 1 over Rxy equals, common denominator is R naught R and this is R naught plus R. We need Rxy. Then Rxy equals R naught R over R plus R naught, right? R naught R over R plus R naught. Next, B. The voltmeter now appears to have been connected across Rxy. Appears to have been connected between Rxy. Under this situation, will the reading of voltmeter be equal to the value indicated by an ideal voltmeter? Ideal voltmeter connected across Rxy. Yes or no? Justify your answer. Right. Now, first you have to know what an ideal voltmeter is. Right? If an voltmeter is ideal, this is the explanation part. Listen. Right? Not the answer. This is the explanation. Right? If an ideal voltmeter, in an ideal voltmeter, resistance is infinity. In an ideal voltmeter, resistance is infinity. When resistance is infinity, no current flows through the voltmeter. No current flows through the voltmeter because we know if a current flows through voltmeter, then it absorbs some voltage and it is going to do some error, right? Have some error when measuring a reading, when taking a reading, right? So that's the exact reason why we had potentiometer as a precaution. No? We had potentiometer as a precaution, right? Voltmeter के error එකක් තියෙනවනේ, voltmeter के error එක නැති වෙන්නනේ potentiometer එක use කරේ, right? So ideal scenario එකක් නම් වෙන්න ඕනේ. In ideal case, right? Internal resistance of voltmeter is infinity. When internal resistance is infinity, there's no current flows through the voltmeter. There's no current flows through the voltmeter. Right, now back to the question. Now resistors are connected here as this. Then voltmeter should be here like this, no? Voltmeter should be here like this. Now resistors are connected like this, right? And voltmeter appears to be connected. The voltmeter now appears to have been connected across Rxy. Across Rxy, right? It appears to be connected across Rxy. Resistors appears to be connected across Rxy. If this is Rxy, now voltmeter appears to be connected across Rxy. Something like this. Something like this. Now Rxy represents total resistance. Rxy represents total resistance. When Rxy represents total resistance, right? Then total current flows through the resistor only. Total current flows through the resistor only. Right? Voltmeter के resistor එකත් ඒකට factor කරලා ඉවරයිනේ. We have already factored the resistance of voltmeter into Rxy. Right? That is inside the Rxy now. Right? Then no current flows through this voltmeter now. Because current flows through the resistor. Resistor එක මම වෙනම අරන් තියෙන. Resistor is already separated now. Then no current flows through the voltmeter. Therefore, this is equivalent to the ideal case. Then we can say it is yes. Yes. Justify your answer. Since no current flows through voltmeter, it's working as it's working as an ideal voltmeter. It's working as an ideal voltmeter, right? There's a small thing in there. The small thinking, right? They thinking nigga. Hitan no I take put thinking nothing. You know. Have to think. Have to think. Right? Next. See, if V is reading, V is the reading of the voltmeter and I is the current through the ammeter. Write down an expression for I in terms of V, R naught and R. Right. Now, if a current I flows through ammeter, see, if a current I flows through ammeter, that same current flows through RXY, no? Because now equivalent between here, equivalent of V and R, equivalent of V and R is RXY now. Now the same current flows through RXY. Same current flows through RXY. Then apply delta V equals IR. Apply delta V equals IR. Delta V equals IR. Right? Then delta V is V of the voltmeter. V. I is I. And R is RXY. R is RXY. RXY is already simplified. Plug that here. Then V equals I times RXY was R naught over capital R plus R naught. Write down an expression. This is enough. Expression na kidhar aaye hone. That is the expression. Right? V equals I R naught to R plus R naught. I R naught to R plus R naught. Right? D. Rearrange the expression given in C to plot a graph of 1 over V on y-axis and 1 over R on x. Right. Then make 1 over V. Sorry, I over V. 1 sorry, I over V. I over V and 1 over R. Then make I over V की subject करेगा right? Subject I over V from this equation. Right? From this equation, subject I over V. Then when I over V is subjected, make the equation equals, this is the equation we have got. V equals I times R naught over R plus R naught. Subject I over V. Right? Cross multiply V to the other side. Then it becomes R plus R naught over R naught. Right? Then y-axis is okay. X-axis is 1 over R. X-axis is 1 over R. To create 1 over R, we can divide both terms on the numerator using R naught separately. Then this is I over V equals, this can be divided separately, R naught plus simple R naught, R naught. Right? These terms are going to cancel. Capital R to capital R naught to R. Right? Then we can keep the final answer as I over V equals, right, 1 over capital R plus 1 over R naught. Right? Then this is our y-axis, this is our x-axis, and this should be the intercept. Y equals x plus c, because m is 1, that is mx plus c. M is 1 here. M is 1 here. Right? M is 1. M is 1. Right? Next. E. Draw the shape of the graph expected in D above on the set of axes given below. Right. Then that is x plus c. X plus c means that is mx plus c. M is 1 now. M is 1. Right? Mx plus c tamai. M is 1. M is 1. Then mx plus c kila kiyanne something like this. Mx plus c. Draw the shape of the graph. Right. Shape is drawn. Next. Write down an expression relating R naught and the relevant information extracted from the graph. You can see 1 over R naught is with the intercept, no? Right? Which means intercept of graph equals, see, intercept C of graph is 1 over simple R naught. Write down an expression relating R naught. Right? Relating R naught. Then the expression is C equals 1 over R naught. C equals 1 over R naught. Expression relating R naught. C equals 1 over R naught. C equals 1 over R naught. G. If you are asked to perform an experiment in the laboratory if you are asked to perform an experiment in the laboratory and plot the graph mentioned in E above, name the item which you would use for R. Right. Then here R is a variable. R is a variable. Right. As variable resistors, we only have two options in lab. Right. In the laboratory, we only have two options in the laboratory. One is rheostat. Rheostat is used when you need to get a variable resistor, right? Or if you need to change the variable resistor to any value as you wish, right? All continuous values, any value can continuous values. And if you need to change R in finite values, finite or distinct values, finite never distinct, right? Monahari values, if you need to do it for some given values, right? Distinct values, we are using resistor box. Rheostat and resistor box. Right. Now in this case, we need some distinct values of R, right? R world value graph. So that is a distinct value of R, then resistor box is used. Resistor box. Resistor box. Right. H. Suppose the resistance R0 is now removed from the circuit shown in figure 1. Assume that R0 equals 1000 ohms. Capital R0 is removed. Capital R0 capital R0. This one is removed. This one is removed. Right? That one is removed. And internal resistance of the voltmeter is given as 1000. Internal resistance of the voltmeter is given as 1000. Consider the magnitudes of the following voltages. The reading of the voltmeter, say V1. Right? Reading of the voltmeter. Second one, the voltage generated across XY when the voltmeter is removed from the circuit. When the voltmeter is removed. When the voltmeter is removed, that's a good point. Always when the voltmeter is connected, it absorbs the voltage. Right? Always when a voltmeter is connected, it absorbs the voltage. Right? Okay, potentiometer issue. The issue we had to choose potentiometer. Right? Always voltmeter is connected. When voltmeter is connected, it absorbs the voltage. Right? It absorbs a small voltage, small current. Current means IR drop then a voltage is absorbed. Then if the voltmeter is removed, then the actual value, actual voltage will be there across X and Y. Right? Actual voltage with the actual potential difference will be there across X and Y. Third scenario, if a digital multimeter having an internal resistance 10 mega ohms is now connected across XY. The reading of multimeter, say V3. Reading of multimeter, say V3. Right. Write down E0, V1, V2, and V3 in ascending order according to their magnitudes in ascending order. Right. Minimum voltmeter reading should be the reading now. Right? It should be the reading now because it has a resistance 1000 ohms. It has a resistance 1000 ohms now. Right? It has a resistance of 1000 ohms. Right? Lower the resistance, higher the absorption of voltage because resistors are in a parallel combination. Resistors in a parallel combination nekkane. Toda api kalanut දැන් කතා කරානේ. ඕක ideal case එක වුණොත් එහෙම resistance එක infinity වෙනවා. When there is ideal, no current flows. Ideal case එක වුණොත් තමයි infinity වෙන්නේ. Then more towards the zero side, which means that is deviating from that ideal scenario. එතකොට යාගේ රේඛ වැඩි. Right? More towards the higher side, towards infinity, higher side. Right? Mega ohms වගේ value වලට යනවා නම් or mega giga වගේ values වලට යනවා නම් then that is more towards that higher side. Then error is less. Right? එතකොට මේකේ වැඩිම error එකක් තියෙන්නේ. When the voltmeter is connected now. Right? Then highest error means that's a minimum reading because higher voltage is absorbed. When higher voltage is absorbed, the reading is minimum. Then V1 should be minimum. Right? Then if the voltmeter is completely removed, the actual value between X and Y will be measured. Now, other than that, before that, we have a 10 mega ohm scenario. No? 10 mega ohms, a higher resistance. Higher resistance means lesser voltage absorption, which means a higher reading is read. Then V3 comes next. V3 comes next, right? And then I can easily decide that battery is the highest voltage here, because a part of the battery, a small part from the battery, is acting across the resistor. No, battery total only a part of the battery. No, battery is the highest. Since battery is the highest, then V2 should be in between. Then V2 and battery is the highest. Right? This is the order, ascending order. Right? Again, a small thinking part. After these first first 7-8 questions we had. Right? Okay, take it down and you can ask if anything before moving on to the next. You can ask if anything before moving on to the next question. Is it all clear so far? Okay, it seems no questions. Seems no questions. Right? Let's move on then. Next one. Next one. Next one. Right. See, a meter G is given. Figure 1 shows an experimental setup that can be used to determine the temperature coefficient of resistance alpha. Temperature coefficient of resistance alpha of material of a thin wire using meter bridge. An electrically insulated uniform wire of length 5 meters and diameter 0.1 millimeters is wound around a cylindrical piece of plastic rod to make a coil. The resistivity of material of the wire is 1.5 times 10⁻⁸ ohm meters at 30 degrees Celsius. A suitable resistance SC is connected across the left cap of the bridge. Right. Circuit is given. Circuit is given. Right. Can't we take V2 equals E naught? V2 equals E naught. V2 means when this is removed, right? When this is removed. One second. So what about E naught? It's not given that E naught is having no internal resistance. It says point E naught is EMF of the cell with a certain internal resistance. With a certain internal resistance. Then it has an internal resistance. Right? So because of that, V is E minus IR. No? V is E minus IR. Right? That's the thing. Potential difference should be E minus IR. Potential difference is E minus IR. It has an internal resistance. If there was no internal resistance, your point is correct. If there was no internal resistance, then V2 equals E naught, that is correct. But now it has an internal resistance. Right? Clear enough, right? Can I explain the last part again? Last part. This one. Simply, since voltmeter is connected parallelly in a circuit, right? Voltmeter is connected parallelly in the circuit. Higher the resistance of voltmeter, lower the absorption of voltage, right? Higher the resistance of voltmeter, higher the resistance of voltmeter means it's lesser resultant comes no, equivalent resistance comes no, then lesser absorption, right? That's why the perfect ideal scenario is being ideal, no? perfect scenario, ideal scenario. That's why in an ideal scenario, it's supposed to be infinity. It's supposed to be infinity. When there is infinity, when there is infinity, when there is infinite, then no current flows at all, which means no voltage absorption. So simply voltage absorption by the voltmeter, voltage absorption by the voltmeter and resistance of voltmeter are inverse, right? Then higher the resistance of voltmeter, lesser absorption. Lesser absorption by voltmeter means more accurate reading is given. Absorption के लिए नया error. Absorption of a voltmeter is the error it made, right? Then in 10 mega ohm case, higher resistance means lesser absorption. Lesser absorption means, right, less error. Less error means it's reading much closer to the actual value, right? Then that is definitely greater than V1. That is definitely greater than V1 and definitely less than V2 because in V2 the voltmeter is completely removed. Then nothing is in between. Podi absorption there's not even a single millivolt absorption, right? Poddakat absorption, right? So likewise, logically, you have to argue and place that at the correct point, correct place accordingly, right? What do you think in that? Last part is a kind of a creative, a thinking part is given. That's true, right? Now I hope it's clear, right? Second one. Okay, then first question. First question. Find the resistance of coil of wire. Find the resistance of coil of wire at 30 degrees Celsius. Right. Resistance R equals rho L over A. R equals rho L over A. Right. Rho was given. Rho resistivity 1.5 times 10 to the power minus 8. 1.5 times 10 to the power minus 8. Length was 5 meters, right? Yeah. Length is 5 meters. Length is 5 meters, then 5 over area. Take 5 equals to area, then diameter is given 0.1 millimeters. Diameter is 0.1 millimeters. Since diameter is 0.1 millimeters, radius should be 0.05 millimeters, no? Radius. Then we need to write 5r squared. 5 is 3, right? R is 0.05 kg, 5 times 10 to the power minus 2. 5 times 10 to the power minus 2. But that is in milli, right? Milli means 10 to the power minus 3. Then this is 5 times 10 to the power minus 5 in meters. 5 times 10 to the power minus 5 in meters. Then this is 5r squared. Then r is 5 times 10 to the power minus 5 in meters squared. Right? I have to simplify. Right? Then simplify. This is 1.5 times 2. 1.5 times 2. Right? Method 10 sorry, not 10. 25 ne? Hurry. Simplify 10 to the power minus 8. Make a 5. Method 25 times 2 again 50. 50 again 10 to the power minus 10. Hurry. Then this is 5 and 15 10. Then finally 10 to the power minus 9 here. 10 to the power minus 8 above, which means that is exactly 10 ohms. Simplifiable. 10 ohms. Right? 10 ohms. B. What is the measuring instrument labeled as Y in the figure? Y. Right? Meter bridge again idea. In meter bridge, before the slider key, right, we are connecting a center zero galvanometer. Then it should be center zero galvanometer. No marks are given for galvanometer. Right? No marks for galvanometer. Right? It's a must to be center zero galvanometer. Then center zero galvanometer. Center zero galvanometer. Right? C. In the space given below, draw a diagram of circuit that should be connected across the gap X in figure 1. Across the gap X. Right? Before galvanometer, in a meter bridge circuit, we have the safeguard resistor with the switch. right? So it should be the safeguard resistor with the switch. Then there should be a safeguard resistor here, right, with a parallel switch. Safeguard resistor with a parallel switch. Safeguard resistor with a parallel switch, right? 2. What is the purpose of circuit that you have drawn in C1 above? Purpose is that is a safeguard resistor, no? Safeguarding or protecting center zero galvanometer from higher currents, because galvanometers are always very sensitive. Galvanometers are very sensitive, right? If a higher current flows, it burns. If a higher current flows, it burns, right? Then to protect the galvanometer from higher currents, this mechanism is used, right? Always write to the point answers. To protect center zero galvanometer. To protect center zero galvanometer from higher currents. To protect center zero galvanometer from higher currents. Next, copper wires have to be used to connect the coil of the wire to the meter bridge. What type of wires are suitable for this? Copper wires to be used to connect the coil of the wire to the meter bridge. Again, now this coil should be connected. No, when wires gonna this coil should be connected here like this. This coil should be connected here like this to this slot, something like this. It should be connected to this slot, right? But for connecting wires, if you have a higher resistance, if we have a higher resistance, then what actually measures between the right slot is going to be different from the actual resistance across this wire to be measured, right? Again, අපි measure කරන්න යන wire එකත් එක්ක comparatively වාගේ මේ wire එකේ resistance එක වැඩි නම් ඉතින් වෙන resistance එකක් measure වෙන්නේ. Then these wires, these connecting wires should be very less in resistance. They should be very less in resistance. To minimize resistance, we know what to do in terms of wires. To minimize resistance, we know what to do, right? Always short thick wires should be used. Short thick. R equals rho L over A. R is rho L over A. Then if we need to minimize resistance, to minimize R, length should be minimized, right? And area should be increased, right? So therefore, minimum resistance is with short and thick wires, right? That is what we should use, right? Then short and thick wires should be used. Short and thick wires should be used, right? This part should not be, must not be here. Answer with this is the argument I had, right? Argument otherwise marks are given only for the answer you are writing here, right? Explanation, right? Next, what are the other essential instrument and an item needed in the experiment? Other essential instrument, right? Now we know in this setup we are going to have some readings by changing temperature, right? Then 30 it is currently at 30, but when we are finding temperature coefficient of resistivity alpha, right, we are taking minimum of 6 readings by changing temperature, right? Then we need a thermometer to measure this. Then instrument is thermometer. An item to make sure there is a uniform distribution of temperature throughout the liquid, you have to stir it, right? Then we need a stirrer. Item is stirrer. Instrument is thermometer. Item is stirrer, right? Next, if the resistance of coil at a given temperature theta degrees Celsius is R theta, and the corresponding balance length of the meter bridge wire is L centimeters, write down an expression for R theta OS in terms of L. Neglect the end corrections of mid-range wire. Right. If the resistance of coil at given temperature is R theta, then R theta again. Right. Resistance of coil is R theta, which means across this slot here, right, it is going to be R theta. Right. We know any meter which works from Wheatstone principle, right? Then S over L equals R theta over 100 minus L, resistances, ratio between resistances. Then S over L equals R theta over 100 minus L. We need R theta OS, right? Subject R theta OS then. Then R theta OS is given by, R theta over S is given by 100 minus L over L. 100 minus L over L. Right? 100 minus L over L. Next, write down an expression for the resistance R theta in terms of alpha. Right? Resistance R theta in terms of alpha. The resistance R naught at theta equals 0 degrees Celsius and theta. Right. Very straightforward because we have only one equation. We have only one equation in our syllabus, which has a relationship between temperature and resistance. Right? Temperature and resistance. That is R theta equals R naught 1 plus alpha theta. Right? Write down an expression for R theta. That's it. Expression that's it. Very straightforward. Right? That is very straightforward. Next. By combining expressions written in F1 and 2 above, obtain an expression needed to draw the straight line graph of 100 over L minus 1 versus theta. Right. 100 over L minus 1 versus theta. 100 over L minus 1 is going to be y-axis versus theta. Then this is going to be our y-axis. For the hint again, this is going to be our y-axis. That is a hint given. This is going to be our y-axis. And this is going to be my x. Right. Now, for R theta, we have an answer here. Right. R theta. R theta will answer from this. R theta is S times 100 minus L. S times 100 minus L over L. First second karno. S times 100 minus L. R theta is S times. R theta is S times 100 minus L over L. Right? R theta equals me equation R naught 1 plus alpha theta. R naught 1 plus alpha theta. Right. Now, my y-axis is 100 over L minus 1. Right. Now, this is already here. This is already here. Keep it without doing anything. 100 minus L over L equals, this is R naught over S 1 plus alpha theta. Right. Now, if you divide numerator of left hand side by L separately, this term creates. Then that is 100 over L minus L over L. Right. And multiply the bracket. Simplify the bracket on the right hand side. R naught over S plus R naught alpha theta over S. Right. Now, this is 100 over L minus 1. Right. Variable. Then x is going to be theta. No? X is going to be theta. Right. Then we isolate R naught alpha S theta plus R naught over S. Right. Now, this is going to be my y-axis, right? And this is x. R naught alpha OS should be gradient, and this is intercept. Maintain graph here, right? Rearrange the terms accordingly. Rearrange the terms, right? Next, using the parameters of the expression written in F3 above, write down expressions for the gradient and intercept of the graph, right? Gradient R naught alpha OS. Gradient is R naught alpha OS. Intercept is R naught OS. right? Again, very straightforward. Very straightforward. Next, write down an expression for alpha in terms of, write down an expression for alpha in terms of m and c, alpha, right? Now, m is gradient is r naught alpha os, intercept is r naught os, then alpha is given by MOC. MOC. When you take MOC, r naught os cancels, alpha remains. Then alpha is MOC, gradient over intercept. Gradient over intercept, right? G. Calculate alpha using following graph shown in figure 2, right? Then when you are selecting, right? Listen, when you are selecting 2 points to find the gradient, right? We can't take any marked points here. That is the first rule, right? You can't take any marked points here, right? And you have to take any two other random points, and go with exact intersections. Which means now when this is given in the grid like this, right? When this is given in the grid like this, now when the line goes exactly through these grids like this, right? This kind of a point, when it exactly goes through the grid, right? We can easily and accurately take the coordinates. So therefore, such 2 points should be selected, right? නිකන් හරියට කැපෙන්නේ නැති points ගන්න බෑ, right? If you don't have a proper intersection, such points cannot be considered, right? මේ වගේ points consider කරන්න ඕනේ. That is important, right? Now find 2 points for this. Find 2 points. Find 2 points, right? See, 1 point is here. මේ points එක mark කරන්න ඕනේ. I can see 1 point is here. 1 point is here. මේක හරියටම intersect වෙනවා නෙවෙයි. 1 point is here. 1 point is here. And then what about this? This one, මේකත් හරියනේ. Another point is here. Right? මම නිකන් dot එකක් විතරක් තියන්නම් වැඩේ easily. නැත්තම් arrow එකක් දාන්නද? lazy වෙන්න. මගේ එක point එකක් තියෙන මෙතන. One point that I have selected is here. හරියටම intersections තියෙන්න ඕනේ. Right? And the other point I have selected is here, right? On the points there. All right. Those two are the 2 points selected, right? It was the scale readings ganna diyenne, right? We need gradient. Calculate alpha using following graph shown, right? It was a gradient එක හොයාගමු. Gradient is delta y over delta x, right? Then first check the what we call the coordinates here, right? Coordinates එක හොයාගන්න වෙනවා. Coordinates හොයාගන්න නැතුව හදන්න දෙයක් නැහැ නේ. Check the coordinates. Now this goes 10 by 10, no? 10, 20 කියලා again 10 by 10. Then x-axis here is 29, right? Then y goes by 0.1, right? Y goes by 0.1. 0.7 to 0.10, 10 make it say on 0.1, right? From here to here, right? Again 8.8, right? 0.88 ne, 8.8 ne, 0.88. 0.88 මෙන්න මෙතන coordinate එක. ඊට පස්සේ මේ coordinate එක හොයාගන්නත් ඕනේ. right? This is 69 no, right? 69, x is 69 and y එක මේ පැත්තෙන් check කරගන්න. Y is coming to here, right? හරිනේ? Then sorry, then නෙමෙයි. Y is coming to 1 above this one මෙන්න මෙතනට එන්නේ. right? ඒ කියන්නේ 1 ඇවිල්ලා තියෙනවා, another 0.6, then 1.06, හරිනේ? 1.06 then coordinates. Now get the reading. Delta y is 60, sorry, delta y is 1.06 minus 0.88, හරිනේ? 1.06 minus 0.88 over delta x 69 minus 29. 69 minus 29, right? Simplify this. 1.06 minus 0.88 means 0.18, no? 0.18. And 69 minus 29, it's 40. Right? It's 40. This is a gradient. Make a simplify current and this is a gradient of graph. This is a gradient. This is coming as per degree Celsius. Right? Unit then intercept. Intercept because alpha is going to be gradient of intercept. Intercept alpha is gradient of intercept. No? Right? Then find the intercept. Intercept is given. Make it clearly pay now. This point, no? That is 0.75. 0.75. Then alpha is given by gradient of intercept. Gradient is 0.18 over 40 over intercept 0.75. Right? Simplify. 0.18 over 40 times 0.75. Right? Then this can be written as, if two decimals are shifted, 18 over 40 times 75. No? 18 over 40 times 75. Right? By 3 make common cancel and by 3. This is 3 times 6. 3 times 25. Right? Here's a by 2. 2 times 3. 2 times 20. Then 3 over, final answer, 3 over 500. 3 over 500. They can make Ganda simplify, 3 over 500 is simplifiable because 3 over 5 is 0.6. Right? Then 3 over 500 is simplifiable. 3 over 5 is 0.6. Again, 6 times 10 to the power minus 3. Right? Then this is 6 times 10 to the power minus 3. 10 to the power minus 3 per degree Celsius. 6 times 10 to the power minus 3 per degree Celsius. It is simplifiable. Simplifiable. Right? It's probably simplifiable. Fine, a small calculation. And be very careful when you are selecting 2 points because always it should be 2 points, 2 further points, right? With exact intersections, and they should not be the points given, right? If you have more than one possible pairs, listen, if you have more than one possible pairs, best option is going with the furthest pair. Best option is going with the furthest pair because that is the pair with minimum percentage errors, right? Higher the distance, lesser the percentage error, right? All right. Next. That's it. Then before moving on to next question, any questions on this one? So I can't select mark points because all mark points are not satisfying the curve. Curve is in between, right? See, mark points are here and there. That is not on the curve, right? That's how always it happens in a experiment, right? Mark points are like usually around the curve, not on the curve. They are around the curve. Right? Keep that in mind. Otherwise, if you select it from mark points, no marks are given. Right? Even if a mark point satisfies, we don't consider mark points because they are biased points. Right? Curve ke තියෙන unbiased points. What else? Anything else before moving on to the next? No, all good. Okay. Next one. Next one. Figure 1 shows a part of an experimental setup to determine the resistivity rho of a material of a given wire with the aid of a meter bridge. Right. The resistance value of resistor box is R. Resistance value of resistor box is R. And the resistance of given wire is S. Right, again make resistance of given wire is S. The length of the meter bridge wire AB is 100 centimeters. Right. A center zero galvanometer has to be connected between point C and D. A center zero galvanometer has to be connected between C and D. Hari, අපි එක දන්නවනේ එතෙන් එන circuit එක මොකක්ද කියලා. C and D. To protect the center zero galvanometer in the circuit in figure 2 can be used. Right. ඒකත් අපි දන්නවනේ. Right. Safeguard resistor. Name the type of key K2. Right. We have two main types of keys in our labs. Right. One is tap key. The other one is plug keys. Tap keys are used when we need an instant current or when you need to connect the circuit at a point instantly, right? If you need to connect the circuit for a small period of time, split of time, then tap keys are used, right? If you need to have a constant steady current throughout a period of time, plug keys are used, right? Now here we have to keep this shorted until the experiment is done. No? Then tap keys cannot be used. Tap key use karo tap karake ninda one. If the tap key is used, you have to tap it. If hands are taken off, it is going to untap. Then plug keys are used. K2 is a plug key. K2 is a plug key. Right, man. Class එකත් explain කරා. When we are doing meter bridge and potentiometer both. Second one. Select the suitable value for the resistance X from the resistances 1 ohm, 10 ohms, 100 ohms and 1000 ohms. For X, no. X is the safeguard resistor. X is the safeguard resistor. Higher the safeguard resistor, lesser the current it flows through the safeguard resistor. No? Higher the safeguard resistor, higher the value of safeguard resistor, lesser the current flow it flows through the resistor. Lesser current flow means higher protection. Lesser current flow means higher protection. That is how it should be then. Maximum possible resistance is the most suitable one. Then we'll go with 1000 ohms. 1000 ohms. Right? Logic එක මම ඕනනම් කියන්නම්. Logic එක මම කිව්වා මම ලියන්නම් ඕනනම්. Right? That should be 1000 ohms. Should be 1000 ohms. And the logic is, listen, logic is higher the resistance, lesser the current. Right? Lesser current means higher protection. Higher protection. Right? Higher protection. No logic. Higher protection. Right? Next. Before taking measurements, how do you check whether the circuit is connected properly? Right? We are doing the same thing in potentiometer and meter bridge both. Right? First of all, you have to keep the slider key at A. At A and B are labeled, right? Yeah, at A and B are labeled because they are standard labels. A means positive terminal of meter bridge wire, B is negative terminal of meter bridge wire, right? So first you have to keep the slider key at A and B respectively, and you have to check whether the deflection of center zero galvanometer from one side to the other. Check whether it deflects from one side to the other. If it deflects, you can your connections are correct and you can have a balance point. If not, there can be improper connections, right? Then you don't get a balance point. And before taking measurements, how do you check whether the circuit is connected properly? By keeping slider key, right? Concise answers. Concise means you have to answer to the point. Short and sweet answers to the point. Always answer to what is asked, right? What is questioned. Don't go around the question, right? Don't wander around the question. Don't go around the question, right? Answer to the point. Concise answers are expected, right? By keeping slider key at A and B respectively. At A and B respectively. And checking whether center zero galvanometer G deflects from one side to the other, deflects from one side to the other, passing 0, deflects from one side to the other, passing 0, deflects from one side to the other, passing 0. 1 second. One side to the other, passing 0. One side to the other, passing 0. Right? That's a complete answer. Right? Memorize theories, recall theories, right? අපි theory වලදී මේ ඔක්කොම discuss කරලා තියෙන්නේ. ඒ ටික මතක් කරගෙන හරියට මෙතන ලියන්නයි තියෙන්නේ. Right? So you have to answer to the point. Give me 1 second. Right? Take it down. Give me 1 second. Right. Next one. See, when the resistance value of resistor box is R, balance length of the meter bridge wire is L in centimeters, write down an expression for ROS in terms of L. Neglect the n corrections of the meter bridge wire. Right. See, now the meter bridge is given as R to L, S to 100 minus L. No? Then the ratio is R over L equals S over 100 minus L. R over L equals, right, S over 100 minus L. We need ROS. Then subject ROS. ROS is given by L over 100 minus L. L over 100 minus L. ROS is given by L over 100 minus L. Right? Next. For R equals 9 ohms, 26 ohms, and 56 ohms, the balance lengths are 27 centimeters, 52 centimeters, and 70 centimeters, respectively, at 30 degrees Celsius. What is the most appropriate value for resistance R that must be used in order to determine the value of S accurately? Give the reason. Right. Now, the logic here is you have to check this with the balance length. You have to check this with the balance length. You have to check this with the balance length. Right? Balance lengths are like 27, 52, and 70. No? Right? Always when balance length is closer to the middle point. Right? Closer to the middle point. Closer to the middle point. Percentage error we make in both sides are minimum. Right? Then closer to the middle point, percentage errors are minimum. So therefore, always we will be choosing the middle point, closer to middle point. We prefer more closer to middle point to minimize percentage errors. Right? If the balance point is biased in one direction, biased to one direction, right, to the lower side or higher side, then percentage errors are higher. Right? So therefore, 52 for 52 according the respective one is 26. No, then we'll be going with 26. Value is 26 ohms. Value is 26 ohms. Reason is about percentage error. You have to explain it. Right? Percentage error ka patten make explain karna. You have to explain it using percentage error. Right? Minimum percentage error occurs when minimum percentage error occurs when balanced point is close to middle point. Close to middle point. Right? करना है. So always we prefer to have the balance point in the middle when doing the experiments, right? That's a practice we have to minimize percentage errors, right? Potentiometer එකත් මේකෙත් එහෙමයි අර එකපාරම මතක තියාගන්න because potentiometer and meter are very two comparative instruments, no? Right? Two comparative instruments. In potentiometer also that is same. In potentiometer also that is same. Right. To calculate the most accurate value of S using the relevant balance length and R. Right. Then we know R of S equals L over 100 minus L, no? Then R of S equals L over 100 minus L. Right. Now calculate the most accurate value of S. Now R is 26. R is 26. And 26 of S equals L. Now L is 52. Right. L is 52. Balance length is 52. Then this is 52 over 100 minus 52. Right. Then 26 over S equals 52 over 100 minus 52 again 48 ne 48. See, this is cancelable. 26 times 2 maybe 2. Right? So maybe 2 again 24. Which means S equals 24 ohms. S equals 24 ohms. Right? It's a normal calculation. 24 ohms. Right? Alright, take it down. Next. E. The values of diameter measured in 4 different places in the given wire are 0.39 millimeters, 0.40 millimeters, 0.40 and 0.41. And the length of wire is 48 centimeters. Length of wire is 48 centimeters. Calculate the resistivity of material of the wire. Take phi equals 3. Right. Then for diameter, we need the average. Right? Average for the diameter, we need the average. No? Then average value of diameter. Average diameter is 0.39 plus 0.4 plus 0.4 plus 0.41 over 4. Right? 0.39, 0.41 means again that 0.4, no, again make answer again 0.4. 0.40 millimeters. Now the average is 0.40. Average diameter average diameter is known. Right? It is found. Then, and the length of wire is 48 centimeters. Right? Calculate the resistivity. Calculate the resistivity. Resistivity kya R equals rho L over N. Right? Abhi equation and the other thing I think I didn't remind you at the beginning. This Sunday we'll be having the thermal experiment seminar, right? Where all the experiments in thermal will be discussed, right? So it will be happening this Sunday. It will be happening this Sunday, 7th, right? It will be happening on 7th Sunday, right? Thermal experiment seminar or thermal practical seminar. Thermal practical seminar. Thermal practical seminar. Right? 7th Sunday at 7 p.m. Right? 7th Sunday at 7 p.m. Physically, I'll be at Lisa Corona. And YouTube Live will be given for other students. Right? Keep the date saved 7th Sunday at 7 p.m. Right? Thermal practical seminar. Right. Then we know our equation is R equals rho L over, right? R equals rho L over A. Then rho is given by RA over L. Rho is given by RA over L. හරිනේ. මේක ප්ලග් කරගත්තා නම් හරි. rho is given by RAOL, right? Then rho equals R. R was determined as 24, right? A pi r squared, pi is 3, right? Pi is 3, and radius diameter is 0.4. Then the radius is 0.2 millimeters. Then it should be 0.2 10 to the minus 3 squared. Pi r squared, darn it. Pi r squared. Then over length was given 48 centimeters, 48 centi 10 to the minus 2. Right? Have to simplify this. This cancels 24 and 48. 24 times 2, right? Then simplify the rest. 3 times. This can be written as 0.2 times minus 10 to the minus 3 means 2 times 10 to the minus 4. Then 2 times can make a 4. 10 to the minus 4 can minus 8. Over this is 2 times 10 to the minus 2. 2 times 10 to the minus 2. Right? Then 2 to 4 cancels 2. Then rho is 6 times 10 to the minus 6. 6 times 10 to the minus 6. Resistivity is in ohm meters. Right? 6 times 10 to the minus 6. 6 times 10 to the minus 6, that is in ohm meters. Right? Take it down. Right. Next, take it down. Finished. F. When the above wire is kept at constant temperature of 100 degrees Celsius in an oil bath for R equals 20 ohms, the resistance box. R equals 20 ohms in the resistance box. The balance length is 40 centimeters. Right. Calculate the temperature coefficient of resistance of the material of the wire. Right. Now, first thing, resistance of wire is not given. Right. We have to find it. Then again, we can use this equation we have proved. ROS equals L over 100 minus L. Now R is 20. R is 20. Over, I need to find S. Right? ROS. L over 100 minus L. L is 40 now. Then 40 over 100 minus 40. 60. Right? Then 20 over S equals 40 over 60. Right? Which means, simplify this. S equals, cancel, right? 20 times 2, then 30. Again, S equals 30. S equals 30 ohms. S equals 30 ohms. Right? If that is known, we know R theta equals R naught 1 plus alpha theta. Then use this equation. R theta equals R naught 1 plus alpha theta. Right? Now we know two different temperatures. Initially it was at, what was the temperature? 30, right? Initially it was at 30. Initially it was at 30, right? It was given somewhere. Where was it? Here, right? It is at 30. Initially it is at 30. Right? Initially it is at 30. Right? එතකොට අර අපි කලින් use කරව අපි හොයාගත්තු 24 කියන level එක ආවේ 30 වලදී. It was at 30. 24 කියලා level එකක් අපි මෙතන calculate කරගත්තානේ. කො නේද? 24. 24 is at 30. Right? එහෙනම් මගේ එක point එකක් ඒක. Then R theta is 24 at 30 equals R naught 1 plus alpha present temperature 30. And second scenario is here. Now there is 30 ohms, R naught, 1 plus alpha, temperature is 100. Divide these two. Right? Then we need alpha. A small simplification to find alpha. Right? Then 24 over 30 again by 6 is cancelled, 6 times 4 and 5. R naught cancels. Right? Then simplify. 4 over 5 equals 1 plus 30 alpha over 1 plus 100 alpha. 1 plus 30 alpha over 1 plus 100 alpha. Right? Then cross multiply. 4 plus 400 alpha equals 5 plus 5 times 3 again 150 alpha. Then 5 minus 4 is 1. 5 minus 4 is 1. 400 minus 150 is 250. Then 250 alpha equals 1. 250 alpha equals 1. මේකත් simplify වෙන්න දීලා තියෙනවා. Right? නිකම්ම simplify වෙනවා. Alpha equals 1 over 250. Then 1 over 250 means 1000 over 250 is 4. 1000 over 250. Then 1 over 250 is 4 times 10 to the minus 3. 4 times 10 to the minus 3. Alpha is in per degrees Celsius. Right? Another small calculation. Right? Write it down. බලන්න මේකේ flow එක. එතකොට resistance එක වෙනස් කරා. resistance එක නෙමෙයි box එකේ. resistance box එකේ වෙනස් කරා at 100 degrees Celsius. Then using our same equation, first we can find the respective resistance of wire S at 100, right? That was 30. Then we have two different scenarios, two different temperatures to apply our equation. R theta equals R naught 1 plus alpha theta. Right? ඒක දැම්ම නම් හරි. G. For a certain type of material, the temperature coefficient of resistance is negative around room temperature. Name the type of material. That's straightforward. Right? That's a theory actually. That's a theory part that is coming from a theory part. Right? Temperature coefficient is negative in semiconductor material. Right? In semiconductor materials. That's why we write this equation for semiconductors. We apply this equation for semiconductors as R theta equals R naught 1 minus alpha theta. Right? මෙහෙම ලියන්නේ semiconductors වලට. Right? The actual reason is මේකේ reasons explain කරනවා. reason එක මේක. අපි variations හදලා තියෙනවා theory class එකේ. R and rho changes with temperature. Of a semiconductor, it decreases. When temperature increases, R and rho decreases. Right? That's why alpha is negative. Then that is semiconductors. Material is semiconductor material. Semiconductor material. Semiconductor material. Right. That's it. So I discussed three structural essays came from electricity, right? Now, even in these three, you can see some similarities, no? Right? That's how it is. Right? Make questions. Take a practice කරලා ගියා නම් එන question එක අනිවාර්යෙන් කරන්න පුළුවන්. Right? Without being worried, right? Easily you can do the question what is to come, right? What is to come this year, right? If you have practiced these questions, because they are very much similar ones, right? For the last part, there can be a small thinking, but otherwise more or less the same. That is more or less the same, right? අපිට ඉතින් experiments එක දන්න ඕනේ. අර first one තියෙන්නේ determination of internal resistance of a cell using that voltmeter and ammeter. ohms law එක use කරලා ඒක ඊට පස්සේ potentiometer එකේ තියෙන experiments එක තියෙනවා. ඊට පස්සේ meter bridge එකේ තියෙනවා. ඔය විතරයි තියෙන්නේ. Right? They are very much same. Right? Any questions from these three structured essays we discussed today? Or is it all clear? You can ask if any questions now from these ones we discussed. I can give you like 1-2 minutes if any questions. Is everything clear? Okay, it seems so. Then we'll stop the sharing. Clear. Okay, good. All right. Then we have come to the end of today's discussion also, right? For next week, again, you can get all updates through the channels, what I'm going to discuss, right? So let's see. Sometimes I might be discussing few more questions from few more essays from electricity, right? Or else, I'm planning to discuss some thermal, right? Thermal, then structured, thermal structured, then oscillations, waves structured, ඔය වගේ structured ටිකක් popular ඒවා. Popular questions which are coming, right? ඒ වගේ ටිකක් discuss කරන්න හිතාගෙනත් ඉන්නවා. And as I told you, we'll be having our thermal experiment seminar, practical seminar this Sunday, right? So, that will be happening physically at Lisa Center Horna, and it'll be Islandwide online on YouTube live, right? So either way, you can join and cover it up. We'll be discussing all the experiments in thermal that day, right? There are 6 experiments remaining now in thermal after all the revisions made in these last revision. After the last revision, then we'll be discussing all the thermal experiments there, right? All thermal experiments there, right? Then without any div, we'll wind up if no questions, right? Again, what I need to say is utilize the time here, utilize the time, right? Just 9 weeks, and this 9 weeks is going to decide your entire life hereafter. That's the thing, right? This 9 weeks, just 9 weeks here on now, and these 9 weeks is the most critical 9 weeks you have in your lifetime now, and that is going to decide who you are going to be in your life, right? In your life means in your entire life, your career, your field, right? Field එක career එක ඔක්කොම වෙනස් වෙන්නේ ඒකෙන්නේ, right? So work hard, manage your time, right? That is how you manage, because all of us has got the same amount of time availability, right? All of us has got the same availability, but the utilized time is different from student to student, right? From person to person, right? The utilized time of the day by me is not the utilized time of the day by you, and utilized time of the day by you for studies is not the utilized time of the day by another different student, right? So that's up to you, right? Whether you are utilizing 18 hours from 24 hours of the day, or whether you are utilizing 16 hours, 15 hours, right? 14, 12. So likewise, that's up to you, right? So work wisely, right? And study wisely and manage time accordingly, right? And utilize this time productively. That's the thing, right? Productively, don't waste it, right? Even if say 1 minute is wasted for some reason, you won't get any chance to recover that 1 minute until you are sitting for the exam now. That's how critical the time now is, right? Okay, then no questions, we'll wind up, right? See you in the next class. So next S2 discussion, right? Stay safe, and good night and goodbye. See you.